Welcome back to part 3 of our series on how to solve SAT math problems. So what we've been doing so far is going through questions that are stylistically and contextually similar to those that you would find on an SAT test. We've done 13 questions, and the purpose behind this is to show you how a teacher would approach each question. Now, once again, I have not read through any of these, so I'm answering them for the first time much the same way you would be if you were taking your SAT. The best thing to do is to practice, obviously, and this practice test will help you out. Question 14 reads, if the surface area of a cube is 384 centimeters squared, what is the volume of the cube? Okay, so a cube is a perfect three-dimensional shape where all the sides are the same length. If we're told that the surface area of a cube is this much, what we can do is map out what a cube looks like. So a cube obviously will have perfect squares all throughout its map. 1, 2, 3, 4, 5, 6. So there are 6 squares making up a cube. And if we add up all the areas of these, if we add them all up, we end up with 384. So 384 is equal to 6 times the area. From here we can actually find out what A is, so we can get the individual area of one of these squares. So I'll divide both sides by 6, 384 divided by 6. Let's see where that takes us. 384 divided by 6 happens to be 64. So let me write that down. 64 centimeters squared. That's the individual area of one of these squares. And we can find the side length of all of these by square rooting this number, because remember, the area of a square is length times width, or side times side. So if the length and the width are the same, we can say side squared, so we square root. So let me square root that, and once I do, I get 8 centimeters as a side length. The good thing about this now is that I know the volume of a cube. The volume of a cube is side cubed. Length times width times height, they're all the same, so it's like saying side times side times side. 8 to the power of 3, I'll use my calculator. 8 times 8 times 8 is 512. So I'm going to assume that the answer is C. In question 5, in the diagram above, what is the sum of the measures of angle X, Y, and Z? This is interesting. No information has been given about this, but there is a rule with triangles. I recall teaching this, that if you add up this angle, that angle, and that angle, all the exterior angles, and this is the case for every shape, not just triangles. So it works for squares, 5-sided shapes, 6-sided shapes, doesn't matter. If you add these up, it ends up giving you 360. And look at this, the answer is 360. It has to be. Let's move on to the next. That was easy. Took very little time. Given the following figure with one tangent and one secant drawn to the circle, what is the measure of angle ADB? So they want the angle here, which I've called theta. And this one's interesting because you need to know properties of circles. One of the properties of circles is that if you have a tangent connected to the circle and a secant connected, or going through the circle, that's the secant line, it goes through 2 points through the circle. The rule is that the far arc, the one labeled 110 degrees, and the inner arc can be subtracted. And the angle of the vertex connecting them is half of that difference. So 110 minus 60 divided by 2. This part is equal to 50 divided by 2, 25. Do we have a 25? Yes, we do. So you may want to touch up on those properties. Another such property is that if you have a tangent line like this, it's perpendicular to the center, the radius here. There are a few others. I don't recall them all by heart, but you should, given that you will need them on your upcoming SAT. Luckily, I knew this one. The next question. Balloons are sold according to the chart above. If a customer buys 1 balloon at a time, the cost is $1 per balloon. If the customer buys 10 balloons at a time, the cost is 0.90 per balloon. If Carlos wants to buy 2,000 balloons, How much does he save by buying 1,000 balloons at a time rather than 10 balloons at a time? So if you were to buy 10 balloons at a time, or if you were to buy 1,000, he gets this price. So if you wanted to buy 2,000 balloons, I suppose it would be 1,000 times 0.60 twice. Let's see if that works. 1,000 times 0.60 times 2. That's 1,200. He would be paying 1,200. So how much money will he save? They're not asking how much money it will be. If Carlos wants to buy 2,000 balloons, that's how much the price will be, according to this. How much money does he save by buying 1,000 balloons at a time rather than 10? Let's see how much it would cost if he went this route, where he did 10 at a time. There are how many 10s in 2,000 balloons? So how many times would he have to go through this cycle? Let's divide these numbers out, and you get 200. So he would have to do this 200 times. What we'll do next is take 1 or 10, the quantity of balloons, 10 balloons times 0.90 per balloon, 1 balloon. We multiply these numbers out, 10 times 0.9, and then multiply this number by 200, which gives us 1,800. So he'll be saving, if he goes this route, he'll be saving the difference of these two, which is 600. That's my answer. Let's move on. If A, B over C is equal to D, and A and C are doubled, A and C are doubled meaning that A becomes 2A and C becomes 2C, what happens to the value of D? So if I modify this and write down 2AB over 2C is equal to D, the 2 and the 2 cancel out, which means that D remains the same. Is that this one right here? Okay. Finally, if the diagram above, line AO or OA is congruent to line OB, it makes sense to know what congruent means. It means the same. So if these are the same, this one and this one, then they are isosceles, right? An isosceles triangle has two angles that are the same, and the lengths making up those two angles, so this one and this one are the same as well. What is the measure of the arc CD? So here we have the angle. They want us to find out what that angle is. I told you that this is isosceles, so that's 55 degrees. And since a triangle has 180 degrees, 180 minus 55 minus 55, these two combine is 110. And subtracting that from 180 is 70. That right there has to be 70 degrees. That's the arc length. And there you have it. Another 6 examples that you are likely to see on your upcoming SAT math test. Please watch part 4 for more.